For today's lesson, we're going to be going over classifying numbers and number sets. So what I want you guys to do for the do now is do the top matching part and also the bottom matching part. So interpreting that bottom right chart and matching each number set with its name. So go ahead, take 3 to 5 minutes, pause the video, complete this, and play once you're done. So the top says match each description with the set of numbers that most appropriately represents it. No repeating. So the first set is telling us is money. So money would most likely be represented by the one that best represents the money would be B. If you take a look at negative 2.5, it would be like negative $2.50, $0, $5.25, $16.75. So that would be B. Number of students in a class. Well, we can't have a fraction of a student, and we can't have negative students, so that would be D. Golf score. Think of golf. Birdie's a -1, bogey's a +1, so that would be choice C. And fraction of a whole. Look at A. Those are all fractions of a whole. So A would be fraction of a whole. And let's scroll to that bottom part. Using the diagram to the right, match each of the number sets with its name. So I'm going to look at the diagram, and I'm going to start with what appears to be the smallest set of numbers. So if you look at the left, we have real numbers, and rational numbers is on the left. And then we have integers are the larger circle. Then whole numbers are the next smallest circle. And then the smallest circle is natural numbers. And notice all of natural numbers is inside of whole numbers. So natural numbers is going to be the smallest number set we have here. But all the natural numbers are also going to be whole numbers because that circle is inside the whole numbers. So when I take a look at this, natural numbers, what appear to be the natural numbers here? If you take a look at A and take a look at B, so A is looking the same exact thing as B, but B has an added 0 on the end that A does not have. So natural numbers is going to be A, and then the whole numbers just add 0 and take all the natural numbers. So whole numbers would be B. Okay, so now let's take a look at C. C, it looks like we have all of the whole numbers also. 0, 1, 2, ... But they're also giving us the negative whole numbers, which that will be, take a look at integers. Every whole number and natural number is an integer because those circles are inside integers. So that would be C for integers. Let's take a look at D. Okay, we have whole numbers and natural numbers in here. We have integers because of -2. And we seem to be adding here fractions. So -3/2 and 1.5. These are going to be rational numbers. And the irrational numbers, you might know this from before, something like pi, a square root that's not a perfect square, that's everything, and E are irrational numbers. And real numbers, this is why it's that's why it's orange and yellow shaded on the top. It's because real numbers encompass all rational and irrational numbers. And we're going to go over that more in a couple pages. So that would be which one has irrational and rational numbers. That is choice F. Let's go to the next page. On the next page, I filled in the diagram with some of the numbers. So if you look at natural numbers, we have 1, 2, 3, 4, 5, and it keeps on going, 6, 7, 8, 9, 10. Whole numbers include 0, and it's all the natural numbers, so 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and it keeps going. that is why, if you take a look at natural numbers are inside of whole numbers. Because every natural number is a whole number. So, when we want to describe what the diagram tells us about the relationship between natural numbers, whole numbers, integers, rational numbers, and irrational numbers, let's first take a look at how natural numbers and whole numbers are related. So because natural numbers are from 1 to infinity, and it's just 1, 2, 3, 4, 5, 6, 7, 8, 9, and whole numbers are just 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, we can say all natural numbers are whole numbers. And it's just going to keep on going like that. So when you take a look at whole numbers and integers, all whole numbers are also integers. Integers just include also the negative whole numbers. So all whole numbers are also integers. And also take a look, the rational numbers include all the integers, whole numbers, and natural numbers, but they also include fractions like 3 over 2, negative 7.49. So all natural numbers, whole numbers, and integers are rational numbers. Take a look at the irrational numbers. They're on their own separate side, like pi, radical 3, cube root of 22. So they aren't going to overlap with the rational numbers, integers, whole numbers, or natural numbers, but the real numbers contain all of the rational numbers and the irrational numbers. So that is how they are all related. We are going to mathematically define every single number set on the next page. What should I be able to do by the end of the day? We are going to be defining each number set and explaining why a number is in that number set. Also, I can create the numbers web and explain how each number set is related. So let's look at the first number set, the natural numbers. Natural numbers, they're denoted with that N. So capital N. And notice it has that, I'll zoom in on that so you guys can see it. Notice how it has that double line there. It's just mathematical notation. Instead of having like just a normal capital N, it shows that we are representing the natural numbers with that notation. And you're going to notice those double lines sort of in the next notations also. So it's the numbers we use for counting. 1, 2, 3, 4, 5, 6, keeps going. And it's the set of all the positive integers, if you want to think of it like that. The next numbers are whole numbers denoted with the capital W, and they just include 0 with the natural numbers. So 0, 1, 2, 3, 4, and it keeps going. Definition: it's the non-negative numbers that can be written without a fraction or a decimal. Non-negative, 0 is neither positive nor negative. So when you say non-negative, that includes 0. It's a set of all non-negative integers. You can think of it like that. It can be written without a fraction or decimal. So you could say 2 can be written as 2 over 1, which makes that a fraction, but no, it doesn't have to be written. It can be written without a fraction or decimal because we can write that as plain old 2. And integers are denoted by the capital Z, and that is a number that can be written without a fractional part. So it can be negative, or it can be positive, or it can be 0. Those are the integers. Rational numbers are denoted with a Q, and those are all numbers that can be written. This is a very important definition. All numbers that can be written as a fraction, A over B, where A and B are integers, and this is also important, B cannot equal 0. Because remember, if B is equal to 0, so say we have A over 0, that's undefined. We can't have a 0 in the denominator. So that would not be a rational number if B was 0. So we have to make sure we say at the end B cannot equal 0. And also, you could also think of it as all numbers that are either terminating. So what does it mean to terminate? A number that terminates is a number like 2.5. You don't need to keep on writing any numbers after the 5. It terminates. You can keep on writing zeros if you want to. You don't have to. That terminates. That ends after the 5. Repeating would be a number like 1 over 3. That is equal to 0.33333, and that keeps on going, which we denote as 0.3 with a bar over it. So that would be a rational number also. Irrational numbers are numbers that cannot be written, so it's the opposite of a rational number. So it's a number that cannot be written as a fraction, a over b, where a and b are integers and b is not equal to 0. And another definition, you can think of it as all numbers that are non-terminating and non-repeating. You have to say both of them, because if it's non-terminating, it could be repeating like 1 over 3. If it's non-repeating, it could terminate like 2.5. So you would have to say it's non-terminating and non-repeating. And that is denoted with capital I. And real numbers are denoted with capital R. And that is a set of every rational and irrational number. Let's go to the next page. Here we have all numbers here. Something we haven't went over, but we will in about 5 days, are imaginary numbers. So imaginary numbers, it's denoted with I, as you could see some I's on that right side, the 9i, I, and negative 12i. Right here, here, and here. But they are found imaginary numbers if you look at the first one, so radical negative 16. So if I were to take the radical of 16 or square root of 16, so I can get, it's the same two numbers multiplied by each other. So 4 times 4 equals 16. That's not negative 16. Negative 4 times negative 4 equals 16. Well, we'd have to do negative 4 times 4 to get negative 16. But those aren't the same numbers, so you can't actually do that. Which is why we cannot have a negative inside of a square root. That's when a number becomes imaginary, when there's a negative inside the square root. We're going to do that more in about 5 classes. Don't worry about that too much yet. We're going to do more of that later. But I just want to introduce that to you guys. So let's go to the next page. I just want you guys to do 1, 2, 3, 4, 5, and 6. Take your time with these. 6, make sure you try A, B, C, and D for 6. Those, which statement is not always true, can be tricky. So pause the video, take 5 to 10 minutes, complete this, and play the video once you are done. Looking at A, it has radical 7, which is irrational, pi, which is irrational, radical 2 over 5, which is irrational, and another number involving pi, negative 7.5 pi. So A is going to be the irrational numbers. Take a look at B. Starts with 0, goes to 5, 10, 15. So those, none of those have fractional parts. And it includes 0. So that would be the whole numbers. Looking at C, we have negative 5 over 2, which is negative 2.5, 12, 16.5, and radical 10. Radical 100 is 10. So this would be the rational numbers, because it includes fractions, where the numerator and denominator are integers. D, I see 72i are the other two imaginary. Yes, they're negatives inside the square root, so this would be the imaginary numbers. E, we have positive and negative whole numbers that don't need a fraction, so these would be the integers. And look at F, we have rational numbers, we have irrational numbers, so these are going to be the real numbers. Number 2, what type of number is negative 7? Well, it's negative, so it can't be a whole number. It's not irrational because it's rational. It terminates after the 7. we don't need to keep on writing numbers. Technically, it could be 0, 0, 0, 0, but you don't need to write that because so it terminates. It is an integer C, which does not describe 107. Well, it's a positive number without a fraction, so it's a whole number. It is an integer because it's written without a fractional part. It is a real number because it's an integer. It is not irrational because it does terminate. Number 4, which would be the most appropriate domain for finding your weight in pounds. So definitely not integers or rational numbers because that includes negative numbers. You can't weigh negative weight. So it's either positive integers or positive rational numbers. So when you think of rational numbers, it could be, like 100.5, 250.25. So you could weigh a fraction of a pound. You're not only just going to weigh like 150 pounds. So that would be choice D, would be best representing the weight in pounds. Number 5, Nancy was asked the question, is the number pi over 2 a rational, irrational number? She says it's a rational number because it can be represented as a fraction. Nancy's not being specific enough. Remember, it has to be a fraction where A over B, where A and B are integers. That is not the case here. So Nancy is incorrect because pi over 2 is an irrational number, as pi in the numerator is not an integer. So we're using that definition of A over B, where A and B are integers and B is not equal to 0 for that. You can word that a lot of different ways. As long as you word it something like this, you're good. And number 6, which statement is not always true? So we're trying to prove one of these statements false. So I'm going to go through A, B, C, and D, and I'm going to try and prove each statement false. So the sum of 2 rational numbers is rational. So let's think of 2 rational numbers. We can add 1 plus negative 49. Let's see if we can get this number to be irrational. That is not irrational yet, so I'm going to cross this off for the moment. The product of 2 irrational numbers is rational. Well, pi times radical 2 would be pi radical 2. You can't do anything with that. That is irrational, not rational, so it would be choice B. And you could keep on trying C and D, and you wouldn't get anything to be false there. So what I want you guys to do for homework, well, first check out the success criteria. I would finish this so you are good with the lesson. And then the homework is just the rest of the classwork. That's it.